We're talking today about breeding for tolerance to worms for the future of sheep farming in England. And I'm Becky Swin. So I manage the Innovative Farmers Programme, and my colleague Laura is also here today. But we're not actually talking about the field lab today. We've given some space to another group who have been involved in a Defra Farming Innovation Path Programme funded project. And so the speakers that we have today include Lucy Giles from Castle Vets, who will give a bit of an intro and a background to the topic. Then Matt Smith from Trefrank Farm, who was the host farmer for the project, and then Adam Hayward from the Moredun Institute, who was the researcher on the project. I won't talk anymore, but we'll have plenty of time for questions and discussion later on. So Lucy, do you want to kick off?
Gonna unmute myself. Rookie error. Spot the farm vet that never does webinars. Sorry, guys. Hi, I'm Lucy Giles. I'm a farm vet working for Castle Vets. For those of you who aren't from the southwest, that's down in Cornwall. We're right on the Cornwall-Devon border. And we've got a lovely range of beef, sheep and dairy. So that's where we're coming from. We teamed up with Trefrank Farm and also with the Moredun Institute and an institute called SEAL to run a Defra-funded project on Trefrank Farm. So along with my colleague Tim Bevington, who is another vet from Castle Vets, our role in it was really to look after the welfare of the animals in the project, help a little bit of project design, and then I managed the project for Matt and Pip as well. So, point of this project, we're going to be talking further about it, so it's just to introduce the concepts really quickly to start with. Matt and Pip Smith at Trefrank Farm breed Romneys and Romney rams to sell. What we want to do is see if their rams would show variation in how they responded to gastrointestinal nematodes, which is just worms, and we'll call them worms from now on. We did it through the 2022 grazing season. Why it's important to show if there is variation is to see if there's anything we can do to make farms more efficient. So anyone who's farming sheep, everything's on a knife edge, profit and everything, particularly single farm payment's been taken away now. It's really important to look at these innovative ideas, which is why we wanted to, approach innovative farmers to talk about the project. We also, as vets, see a lot of resistance to drenches, so wormers that are used to kill the worms in the sheep. We have reported resistance to all of those groups apart from the purple class, and that means that when we're giving the drug, it's not killing off the worms completely, which leads to a real problem, and we've seen massive problems in New Zealand, which I'm sure Matt will chat about a bit. And the third reason why it's important, actually, there is an environmental impact. We're talking about reducing the amount of worm we use. Worm is not great for your biodiversity on your farm. But also, again, efficiency, making things as efficient as we can is good for the environment. So those were kind of our approaches when we applied for the Defra funding, and we were lucky to get the grant. So that was fantastic. A little bit of background, and then Matt will probably take over. But what we were looking at is the history, particularly coming across from New Zealand, of breeding rams and breeding sheep that will basically survive and thrive even though they have worms inside of them. So these animals can have very high worm burdens and still do very well, so they can tolerate the worms, or they can have really high worm burdens, fight those off, you get a low worm egg count, and that's called resistance. So there are resistance traits that are being bred for in the UK already, so rams that will fight off worms. What Trefrank tends to focus on the other side of the coin is the idea that you can tolerate worms. So these animals can have a really heavy burden, actually doesn't impact them as much as we think it will. And that's all part of a resilient animal. Again, I'm sure Matt will explain that better, but it's just to give you guys a basis of where we're coming from. It's a really novel approach in the UK, so it was really exciting to be part of it, and this idea that you can have an animal that tolerates these problems It's just more flexible within the environment. So the way we wanted to do this was looking at the 2022 ram lamb crop. So cast your mind back, it's not last summer, it's the summer before, which coincidentally was one of the worst summers for worms in the southwest that we've ever had. I know I'm talking to people from all over the country, but southwest down here it was pretty grim. Myself and Tim and my colleagues at the vets were regularly seeing animals die from high worm burdens. So it was a very challenging summer to be running this project. We had 200 ram lambs, and that was 16 different sires on those ram lambs. And what we did is we weighed them 2 weekly, and we also took an individual fecal egg count from every single of those 200 ram lambs. So we did a lot of fecal sampling over that period of time. That was every 2 weeks from July to November. And we ran them against a test group. So we had a test group. We didn't want to have a big worm burden, so we could look at the difference and have them as a comparison. And that group was wormed every 4 weeks, but on the same pasture, so we could have a little comparison there. And yeah, it was a really good project to be part of, and we had some great results, which after Matt's spoken, Adam from the Moredun Institute will go into the results that we got. And, you know, without further ado, really introducing Matt and the farmer's view, which I'm sure is what most of you guys will be very interested in. And I think Matt's going to speak a little bit about where the ideas for this project came from, his experiences, and hopefully what you get out of it. Oh, you need to unmute yourself as well, Matthew.
I must have got muted. I thought I'd unmuted myself earlier. Must have been group muted. Okay, yeah, well, thank you for the invite to do this. So, yeah, my name's Matt. Bit of a background, obviously originally come from New Zealand. I've been living here for 11, coming 12 years now. But before that, travelled the world for 14 years shearing sheep, brought up on a sheep farm in New Zealand, and you know, saw all of the things that created the huge worm or the anthelmintic resistance, you know, the bolus that came out. And you know, we went from shearing 60 kilo ewes to shearing 80 kilo ewes, which was really big when you were a kid. And then all of a sudden sheep dying because we had drench resistance very quickly from the bolus concept. So from there on out, got to witness what a lot of good farmers were doing by default. And coming from a farm, always being, you know, looking to go back into farming, kept a pretty good interest in what people were doing and the results. And I've said it time and time again, farmers don't hide anything from a shearer, because, you know, we can hide things from the vet that we don't want them to see. Sorry, Lucy. But they don't want to share the ugly ones. You know, we see everything. So it was, the journey came from learning and understanding what people were trying to achieve and the challenges they faced and how some of them were overcoming them. And when it came, you know, we came here farming in the UK, and we went down the Romney route because obviously I was familiar with it, and coming into a very unfamiliar environment, it was something that I could lean back towards. It wasn't that I thought they were the best sheep in the world. I just knew I had a lot of odds stacked against me. Therefore, something that I knew a bit about seemed like a positive to have behind me. And when we started that journey, I really felt like we weren't getting what I was familiar with. You know, my expectations of how I had been farming and what I'd seen, I wasn't seeing those results. And it was very clear that people were chasing resistance heavily. And while the wormers were working, we were seeing okay results, but we knew that we were relying far too heavily on the wormer. As far as I was concerned, they were still too frequent, and the growth rates before. So if we talk about terminology, we refer to what we're breeding as resilience as opposed to tolerance, only because we seem to follow a little bit of suit of New Zealand. And we have a thing in New Zealand called facial eczema, which is a endophyte in ryegrass that, well, it's a fungus, sorry, that one with foreign pneumonia, the other. It's a fungus in ryegrass that you find. It's a spore that basically attacks the liver and basically renders them pretty useless after time, to be fair. But anyway, so certain breeds were very susceptible to that, and they started breeding for what they called FE tolerance. So why I've been conscious to continue using the word resilience is because I know that at some point we're going to cross paths and we're going to talk about tolerance, and people are going to think, oh, you've got facial eczema there, which I have no doubt in time we will probably face, given the fact we're chasing that. But and the other one was resistance to worms. Now, in principle, initially, there was a lot of emphasis on that, and that to me, from a layman's sort of point of view, it sounded really good because we were going to kill all of these worms. Now, how that was happening was obviously through antibodies. So you were expecting to breed sheep that could create antibodies to kill worms. And in my experience, shearing those farms that were really heavily focused on resistance, they were they weren't great to shear. So I sort of felt that to me probably was not going to be profitable enough when we looked at our grass growth curve, especially here in the UK. One thing we can do as farmers here is grow a lot of grass. Unfortunately, as a general rule of thumb, if you can grow a lot of grass, you have a huge worm burden behind that. You can't get one without the other, unfortunately. And with that, started working on farms, shearing for farmers that were probably you could refer to as quite primitive in terms of their approach, but they'd been doing it for so long, they'd achieved a result, which was looking for tolerance towards worms, resilience towards worms. And they've still got white wormers working on their property, which in New Zealand is absolutely unheard of, to have those still working there. So I did a lot of research into the farms that we wanted to import rams from, and there's no better person to ask than someone who's using their own checkbook. It's very easy to ask someone who has something to financially. So we went and we asked really good farming friends over there that were big farmers. One of them in particular won Farmer of the Year in New Zealand, so obviously rateable towards their knowledge. And out of the 10 good farmers we asked, they all led us back to this one particular farm because of what he was doing and the reasons why he was doing it, and because of the pressure that they were all facing, more people were going to him. So I thought, well, upon those recommendations, we'd approach him. So we went down that route. We imported these rams, and the difference was staggering for us. It was really staggering. Despite our best efforts, a lot of the time to select rams with the worst feck, which by default, actually, on the trial, some of them worked out to be very resilient. But they were the worst ones on feck. So with that, when we had the opportunity to then, obviously we were working with Castle Vets, and the results sort of were what they were. We gathered interest from Tim, who's Lucy's partner, and in the vet practice, before old Matt shoots her. So with that, we were looking at the growth rates and the drench use, which sparked an interest there. And when this trial came up, that gave us an opportunity to put a little bit more data in front of people to make choices, because one of the things that was really knocking me around a little bit was working for a lot of farmers here, shearing. I mean, we're, as far as I'm concerned, we're a small farm. We're only 1,100 ewes and 600-700 deer and 100 cattle, so it's not really a full-time job. And we have a really great young staff member, which is going great guns, so I might as well go off and do something else. And I'm still shearing sheep for other farmers, which I enjoy, but noticing a lot of people suffering emotionally / mentally, because when you're shearing these lambs, and different breeds obviously were having different results, they were hitting a drench resistant problem in certain times of the year. Their lambs were dying, if not looking like they were going to. And it was hard, because although other people were going through it, you're trying to tell them it's okay, everybody else is going through it, but you weren't able to offer any form of advice or solution towards that. So that wasn't very enjoyable for me to see that, and didn't really want to talk about a lot of things until we had a bit of evidence behind us that it was plausible. So getting involved in this trial was great, despite the fact that we were already doing it. A lot of a lot of people try and really overcomplicate simple situations as far as I'm concerned. And I, Jesus, I make two short planks look like a computer when it comes to an IQ. So for me, what I wanted to know with our animals was how big was their worm burden and who was tolerating that best. So we wanted to know, given every environmental impact, what their growth rate would be with a low worm challenge. So a lot of people get quite technical and try and measure different things, protein of grass, sunlight hour, all sorts of things to be relevant to what the growth rate should be for those stock. For me, the easiest thing to measure what the growth rate would be for those stock without worms is sheep in that group, in that environment, without worms, i.e. a control group. So we have always had a control group within the group, which when we do our fortnightly, the trial we with Moredun for structure was fortnightly. We sort of run on a 2 to 3 week because we're looking for a daily live weight, not a every 2 weeks clinical weight. So we would run in the group of sheep, draft off the controlled group. We would take a dung sample too in our layman trial to just measure where our levels were at, and then take an average of those and then look at the rest of the group. And provided they were performing as close to that as possible, remarkably, some of them massively outperformed them, they would stay within the trial without an anthelmintic, because if there was a check to the growth rate, it wasn't necessarily worm related, it was potentially environmentally related, i.e. got too hot, got too wet, that paddock of grass wasn't good enough. There's so many variables. And when we structured the trial with this, it got even better as far as I was concerned, because we were looking at individual worm egg counts, and some of them were staggering and they were performing as well as control group, and some of them were very, very low performance. So the worm egg count wasn't necessarily relevant, linked to high worm egg count, high tolerance. There was some that had a low worm egg count for whatever reason and a reasonably good growth rate at the same time. But on average, the ones of what I would call resistant would have been using so much energy, this is looking at it from the outside, using so much energy looking to kill the worms that it checked their growth rate. So some of those more resistant animals, this is why we use tolerance, because they sound similar. Some of the more resistant animals were having the lowest performance before wormer, a great performance after wormer, but the lower performance before wormer because they were using so much energy to fight the worms. And then if we take a step back to why I believe tolerance has a bigger future than resistance, would be if you look at a classic resistant animal, which would have a low worm egg count, and a classic tolerant animal, which would have a perceivably high worm egg count. If they're in the same paddock, technically, they're facing the same worm burden. So just for ease of maths, a lot of ours would sit at around, God, no, it was scary, quite a high worm burden. 1,000 eggs per gram wouldn't be out of the park for some of ours. And the resistant animal, just for argument's sake, would have a worm egg count of 150 to 200. So in theory, if we look at an anthelmintic wormer, to be licensed had to be 95% effective for it to be licensed. So from the onset, there's the potential for 5% of those worms to have survived and evolved into becoming our anthelmintic tolerant worms. And that in some instances happened quite quickly, in some instances happened quite slowly. So if we sit back now and look at those sheep, those antibodies, like the wormer, have only killed 80 to 90% of those worms. So through evolution, because everything seems to evolve, apart from me probably, through evolution, you can't help but sit back and ponder. And some people would say it's happening, some people would say it wouldn't. But through evolution, the worms that survive those antibodies are going to multiply. That's just how life works out. So by focusing on something heavily that had the same flow rate as an anthelmintic going forward, I also didn't feel that that was going to be a long road, the road for us to go down. The beauty that we would like, we've got a lot more questions to ask, and we've crossed this, we've got a lot more work to do. But on our own trials at home, those worm egg counts, so Tim would say that a highly tolerant animal, highly resilient animal, would be a lot slower maturing. So you've got to appreciate that going forward, that it may compromise the maturity of your ewe lambs if you're looking to tup ewe lambs. However, when those animals are mature, they do seem to just get rid of the worms, because on trials here that we've done, again, laymanly, we would like to do more with it, with the ram lambs that have gone out with FEC counts from, gone out through the trial, they've passed the trial, they've not had no support, they've got a worm egg count going out of into the thousands, which is scary, but they're still doing okay. When we've done dung samples on those February, March, they have almost had a worm egg count of 0 without support. So we're not losing out on that big vacuum cleaner adult animal. We're not losing out on that mature ewe that could potentially pick up, clean, and kill a lot of worms, rightly or wrongly. And I don't know what those answers will show going forward. But the process and the journey for the tolerance especially if we're going into a lot of farms which are heavily under an anthelmintic breakdown, there's not a lot of light at the end of the tunnel, because it's become very clear that seemingly your generation 4 and 5 drenches, especially the generation 4 drench, has established a resistance very quickly. So the 5, the StarTech or the purple drench, now for some of those people is a stopgap. It's not necessarily an answer if it's not managed correctly. So for looking at the future there's no quick fix. None of these things happen quickly. But it's definitely a step in a direction where I feel, if you're starting to see signs of drench resistance, we have had amazing feedback from farmers that are using their own checkbook on selecting the rams here for their tolerance and seeing the results within their own flocks, within their own environment. So, the trial, for me, it was great to be involved in after many, many years of traveling, and always sort of being mentally active, to just come here and mundanely farm sheep and repeat the process sort of wasn't a massive appeal. I say I live here by choice. My wife told me we're living here, so it was my choice. It wasn't that bad, but so for me to be able to work with people like Adam and Lucy was a huge uplift and gave me a lot of enthusiasm towards the project. And like I say, we've got a lot of questions to answer. I know Adam's going to fill you in on a lot more of the information and data. I know we're going to go to questions and answers. So for me, that's definitely a lot more appealing to try and answer a question of something that someone genuinely wants to know the answer to, rather than just me rabbiting on about what we did. But that's sort of us in a nutshell. Like I say, the trial's been awesome. It's really opened a lot more questions. It's answered a lot of questions, but it's opened up a lot more questions. And so no doubt you guys will have some questions for me. I'm going to pass you over to Adam to go through the technical part of the trial, which I'm not going to lie, part of it still confuses me. So good luck. But yeah, we'll speak soon.
Cheers, Matt. Thanks a lot. Right, because I'm a scientist, I'm incapable of talking without slides. So I'm just going to throw up a quick PowerPoint. So yeah, I'm really just going to go through what we did. So, well, first of all, actually, I'm going to outline some concepts. So we heard a lot there about resistance and resilience and tolerance. And as we kind of alluded to, it is actually a bit confusing as to what we mean when we say those things. So I'm going to kind of go through those definitions a bit more to start with, so we all know what we're talking about. I'm going to talk about what we did in the trial, and then I'm afraid I'm going to go into the kind of the technical sort of results section, where we can sort of quantify what we found and put some numbers to kind of the effects that we saw when it came to variation between the animals in how tolerant they were of the worm infections. So if I can just move this on. Okay, so just in case you don't know, so I'm from the Moredun Institute, so that's a livestock disease research institute just south of Edinburgh. So we're out in the sort of countryside just to the south of the city. We're so we do livestock disease, mainly sheep and cattle. We do a bit of aquaculture, pig, poultry, and a bit of wild animal disease as well. We've got sort of high-tech labs at the site. We've got housed animal facilities, and we've also got a research farm where we run a lot of research trials as well. So we're sort of pretty well set up for these kinds of things. And of course, we also work on real-life farms, as we did in this project. So yeah, as I said, I'm just going to outline some sort of concepts. So really, this is kind of fundamental concepts in sort of disease biology, but really, and it applies perfectly well to sheep infected with worms. So the basic question really here is, how do animals deal with those infections? So our sort of baseline is an animal that's susceptible to infection. So if you think about a lamb grazing on the pasture, there's lots of worms, worm larvae on the pasture. The lamb is taking those up, and those worms are growing pretty well inside that animal. So it's got a high worm egg count coming out the other end. And as a result of that, the lamb is suffering. So it's not growing well. So a susceptible animal is one that's not really able to resist the effect of those worms and is showing poor growth as a result. And that's obviously not what we want. What we do want is an animal that's resilient. And so a resilient animal is one where we know it's exposed to worms. So there's worms on the pasture, but it's continuing to grow well. So we know that that animal is perfectly able to deal with those worms. You can see it's got question marks in its belly, and the reason it's got those question marks there is because we've not done a fecal egg count, so we don't really have any idea whether it's got a low worm burden or a high worm burden, but all we know is that despite the worms, it's continuing to grow well. And that resilient animal could be doing one of two things, or it could even be doing a combination of the two things. So Matt talked about this, so resistance. So an animal with a low worm burden, this is strong antibody immune response. It's basically kicking those worms out, preventing them developing, and as such, it's got good weight gain. But as Matt says, that can kind of sometimes come at the cost of those proteins, antibodies are not then being used for growth. Another strategy which can work alongside it or instead of it is tolerance, and that's kind of what our focus is on today. Now, a tolerant animal isn't necessarily good at getting rid of worms, but what it does is that despite a high worm burden, it continues to maintain in its performance. So whether it's in milk yield, reproductive performance, it continues to perform well. And so a resilient animal could be resistant, it could be tolerant, it could be both. And obviously, as scientists, we want to be able to measure these things in sort of reliable ways. Now, resilience is a very easy trait to measure because all you need to know really is how well the animal performs in its environment, no matter how wormy that environment is. And so to measure the resilience of the animal, you just weigh them, and Matt kind of alluded to this. You want to know which animals are performing best in the environment. So here we've weighed two animals. The black one is more resilient than the red one because it weighs more. To look at resistance, you need to do something slightly different. You need to actually measure how well the animal is putting up with or is repelling the worm infection. So two animals exposed to the same levels of infection, we're looking at a worm egg count. And as I'm sure you all know, an animal with a low worm egg count, in this case in blue, is more resistant to infection. And an animal in orange, which is less resistant, has got a high worm egg count. Thinking about tolerance, though, that's much more difficult to measure because we need to know how the animal does under a range of different infection pressures. And so that means that for our blue animal and our orange animal, we need to collect multiple measures of body weight or performance and worm egg count. And so we can look at their performance both at low worm egg count and high worm egg count. And then to look at tolerance, we actually look at the relationship between these two things. And in this case, our orange animal, although it's not doing particularly well at low worm egg count, particularly compared to the blue animal, as its worm egg count increases, it actually maintains its performance pretty well. It doesn't lose much weight. The blue individual, though, as its worm egg count increases, its body weight declines dramatically. And so although that animal does well when it has a low worm egg count, it really suffers when it gets a high worm egg count. So the blue animal there is less tolerant. And this is exactly the kind of data that we wanted to collect during the trial. So just some sort of extra aspects to consider these different traits. As I've kind of alluded to, tolerance is harder to measure than the other traits because you need more information. You need egg counts and you need weights, and you may need to do those things multiple times. An interesting question is whether promoting tolerance or resilience increases pasture contamination. So animals that put up with worms just churn out eggs, and that could be a problem for animals coming onto the pasture that aren't as resilient. But we know from certain research in New Zealand that actually resilient animals tend not to have significantly increased pasture contamination compared to resistant sheep. And that's research that's still kind of ongoing and hasn't really been done in the UK. As I also alluded to, resistance may trade off with performance. So making an immune response to worms means you're I think I lost the connection there.
Yeah, Adam, could you just repeat what you were just saying?
Yeah. Right, there you go. Yeah, so I'll get to the part about resistance trading off with performance. So because you're making an immune response to infection, you're then not using those resources for growing. And the last thing that, in particular in this country, resistance is very well studied. Resilience, reasonably well studied, particularly in New Zealand, but tolerance has really not been well studied. And that's true of sheep infected with worms. It's also true of all sorts of other livestock diseases and really in animal science. People have been breeding for tolerance in plants for over 100 years, but only really starting to see an interest in it in terms of livestock science in the last sort of 10 years or so. So this is a pretty sort of novel trial, I would say. So as I think Lucy mentioned, the trial was 2022. We had 200 Romney Ram lambs. They came from 16 different sires. So some of these are from the UK, and some were resilient animals from Te in New Zealand, where they've been breeding for resilience for 30 years or so. So these are what we expect to find. We expect to see resilience among these animals. The start trial lambs were about 3 months old. And we monitored them, I think, July to November. And then, as Matt said, we also had this control group, which we were drenched 3 times during the study. They were run in the same pasture, but that gave us an idea of basically how the animals would have performed in the absence of kind of worm infection. And so, as I think Lucy's already said, we collected these samples across the whole of the sort of summer and autumn. The fecal samples were collected mainly by Lucy, I think, and then they were basically stuck in an envelope, posted to Moredun, where we've got this big lab where we can process egg counts on a kind of industrial scale. So we get the data back within a couple of weeks, and then the lambs were fasted overnight and then weighed the following morning. So we've got weight and egg count data for these 200 animals 9 times across the season. And when we do fecal egg count, so I'm sure you've seen this sort of picture before, but we're basically looking for these strong-eyed eggs. So these are things like Telidorsagia, Trichostrongylus. These are brown stomach worms, scour worms. We also saw Nematodaris, but we're not really talking about Nematodaris today. And just some kind of headline statistics. So the mean daily weight gain in the study lambs was 52 grams a day. So that's pretty low, and I think you can probably talk more to Matt about the reasons for that, and the stocking density, the really harsh sort of conditions that we had in 2022 certainly contributed to that. For comparison, the control lambs did about 80 grams a day. So even in the absence of worms, the growth rates still weren't particularly high. And I think it's a reflection of the environmental conditions that they faced this year. Another thing is that the average worm egg count across the whole of the study is 415 eggs per gram. So that's pretty reasonable egg count, where you would expect to see that that would start to have an effect on the animals. And it's worth bearing that 415 eggs per gram in mind as we move forward. And so with all this data, we can't just look at it. We have to actually do some statistics on it in order to sort of tell us about what it shows us in terms of how tolerant the animals are. And so we have to chuck this data through a statistical model. I'm not going to go into it. All I'm going to do is tell you that the sort of average relationship between body weight and egg count is this red line. So this is a statistical model, and what this red line translates to is it's predicted that an animal that's got that average egg count of 415 is predicted to be about 350 grams lighter than an animal that has an egg count of 0. So that's basically the cost of having that average egg count in the population. And you can also think about that as being the average tolerance of the lambs to worms. So the average animal is predicted to be 350 grams lighter with that average egg count. But what we're really interested in is how much the animals vary in this number. And so what we can do, because we've got 9 data points from each animal, we can basically draw this same line, but for every one of those 200 animals that we sampled. And what you get is a sort of a big sort of crisscrossing mass of lines that show, and you can probably see there's probably differences in how intensive that slope is. This is a better way to look at it. So this shows you on the bottom there, that shows you the effect of that average egg count on body weight. So you can see in about the middle where that red dotted line is, that's 350 eggs per gram. So that's the kind of average effect. And you can see most of the lambs are clustering around that number. But towards the sort of purpley end, we've got lambs that are predicted to be more than 500 grams lighter. So they are suffering more as a consequence of those worms than the average. And at the top end, you've got a couple of lambs here which you've got incredibly high tolerance because they're only about 50 grams lighter with that average egg count. So they're doing much better. They're doing roughly 10 times better than the least tolerant animals. And because we've got data from 16 different sires, we can also look at differences in the lambs from those sires to see how which sire we might want to breed from for this trait. And because we've only got 16 sires, we've only got 16 lines. So this is a similar statistical model. And what we can do is we can plot each of those 16 different rams, and we can look at the average effect again of that average egg count on body weight. And the red dotted line again is the average, so that's the sort of an average sire. And again, in the dark end, the sire P, so lambs from sire P are predicted to be again about 500 grams lighter with the average egg count. And at the top end, lambs from sire M are only about 210 grams lighter. So they're roughly half as badly affected as the lambs from the worst sire. And so, for example, if you were thinking of breeding for tolerance from these animals, you would pick sire M rather than going for sire P. Okay, so that's a fairly quick rundown of the results of what we found in the trial. So the lambs varied in their tolerance of infection, and this had really quite profound consequences for their performance. And if you do a sort of back of the envelope sort of calculation, we could work out that the least tolerant lambs are about 10 days behind the most tolerant ones in terms of weight gain under that average parasite load. So 10 days, not an insignificant amount of time. And again, lambs from the different sires had varying tolerance of infection, and those from the least tolerant lambs had roughly double the weight penalty of infection as the most tolerant lambs. So a twofold difference. And again, that variation between sires really suggests that tolerance could be improved through breeding from tolerant sires. We've not done any sort of proper genetics because this is quite a really small scale study, but it is at least sort of encouraging. And as Matt said, this was a fantastic project to be involved in. So for Moredun, this was just great because this is working with real data from a real farm with sort of proper environmental conditions. This is exactly the sort of trial that I really love doing. You get really exciting data out of it. So yeah, just thank everyone involved. So there's a few of us at Moredun. So this is the farm. This is the event that we ran on the farm in May last year, where we talked to farmers and vets about the project. So yeah, Matt and Pip have been amazing, and similarly Lucy and Tim from Castle Vets. And yeah, so really good team, really great project to work on. Yeah, we're hoping to sort of get some more money to continue doing this. That's the kind of difficult next step, I guess. So that's me. That's kind of a lame ending, but yeah, that's where we're going to finish. So
I do love that picture. So just for reference for everyone, that was kind of the whole team that were involved. We ran a few knowledge exchange dates. Yeah, was it May 2023? I think towards basically when we finished collecting all the data, coming towards the end of the funding, and we thought, right, we need to tell people about this. So we had over 100 farmers came to the farm, which was fantastic, and then we had about 30 vets all around the Southwest come and learn about it as well. So that was another great part of the Innovate funding from Defra, was that they didn't mind funding stuff like that, which was actually another really great thing about it, is getting a load of people together, and that community side of it as well. But I think Becky was saying we're going to field some questions. If anyone wants to unmute, or if you feel better texting. Oh yeah, so Tony has asked, were the New Zealand rams notably better in the end? Obviously, we have named the ram breeder, so it's up to you if you want to answer that one. I don't know if we went into which one's the New Zealand and which ones were the UK rams. Did you do that analysis, Adam?
We kept it incognito because fairness, you know, we're not here to break that, but the averages were, it was a little bit difficult, and we needed to try, because a lot of the rams that were purchased here because of what we were trying to achieve prior, not all, but the bulk of them were actually purchased on their merit for their worst FEC, which was the least amount of growth rate change following a wormer. So the ones that we'd picked from anyway, in theory, were generally, we did purchase a couple based on FEC, and they were very clearly at the bottom of the pile, because they were selected for resistance, not resilience. But we did have a couple in the top 10, almost top 5, to be fair, but purchased for their worst FEC. So that when you look at people that are looking for resistance, or have been breeding for resistance for a long time, it's a very sharp U-turn, I feel, because you've been going in a direction for a long time. So it's a little bit difficult to pin holes in people that have been chasing resistance, because that's what we've been led to believe. And I think it's very clear, very good to make clear that this trial, we're renowned for being quite hard on stock. It's you see a big fish in a small pond go out into the ocean, and chances are they really struggle. But when you see an average fish come out of the ocean and go into the pond, they do quite well. So that's how, this trial here, and where we want to go with trials, is looking at how we can enhance resilience, i.e. through better grazing, protein, various things. I mean, if you look at what those lambs are on, I mean, to have a worm burden, let alone lack of pasture, it was surprising they even had worms because they weren't eating much. So, yeah, there's a lot more questions to ask. Yes, on average, the ones that were selected or brought in for being tolerant were very good, but that doesn't mean to say that there wasn't tolerance in other lines here, in fairness.
I think as well, just to add that, like, coming at this completely not knowing anything about tolerance and resistance, what I think the trial was trying to show, actually at a really basic level in the UK environment, is that those differences actually exist. So we didn't have evidence in the UK before this trial that you could have animals tolerating the kind of burdens we saw them tolerating. So that was like a really good outcome of this trial, was just the very basics. Any other questions? Just having a look.
I don't think we've got any in the chat at the moment, but I was sent one, which is just about. Could you explain more about the sort of harsh conditions that you mentioned in 2022 and how they were affecting fecal counts?
Yeah. Do you want me to start, Matt, just from like a general point of view as well? So 2022 generally, from a practice point of view, we saw a really kind of hard season because the grass growth was really poor. So in some farms that would be expecting to see like 100 gram a day growth up to 200 grams a day growth, they weren't achieving that, and that was kind of then reflected into the autumn when you're getting a lot of lambs that weren't fat to sell at the normal market. So across the board, we were seeing growth struggles. On Trefrank Farm, historically, what they have done is put a lot of pressure on their ram lambs. So they'll keep them at very high stocking densities and under quite a lot of pressure, because when they sell them, that's what Matt's talking about when he talks about kind of the pond and the sea and the fish, the lovely metaphor that came in there. But basically, they want them to be able to survive in really harsh conditions, so that when they go on to other farms, they can thrive through. These ram lambs, the idea is you want to produce rams to sell as rams and not for meat. So they're not chasing the kind of live weight gains that we see in meat lambs. There are a few other things that contributed towards the conditions on the farm as well, Matt, I think, like that particular year.
Yeah, it was. So I'm not blaming anybody for management, but unfortunately that year my father passed in New Zealand. So I spent a little bit of the time away, and ball wasn't dropped, but things were probably not quite done how. So those rams faced even bigger challenges, because it's one thing, resilience is a broad word when we look at how we use resilience in day-to-day life, which is again why the tolerance word is appealing, but I still struggle with it because of my upbringing with facial eczema. So, in order that the worms are one element of our resilience. So all of these things can contribute to poor performance. Worms, social pressure, lack of protein, bad feet, all these things can contribute to poor performance. So we're looking at all of those, and again, terminologies for you, Luce, everybody's a great boxer when they're punching a punching bag, but what makes you a really great boxer is how you get up after getting punched in the face, and nobody knows how you're going to get up until you've been punched in the face. And here, these poor bastards, they feel like a battering ram. So the challenges here are immense. The challenges that year were some that we haven't seen before. It was a drought that reservoirs are still recovering from in our area. So, yeah, those challenges were high. But it was great in many ways, because one of the things when we were talking to, his name shot out of my head, from Lincoln in New Zealand, was that, are you going to have a big enough worm challenge to run this trial? Well, we nailed that part.
Yeah. Again, from a veterinary point of view, the worm challenge was substantial that year, and we then on top of that had a drought which was reducing the grass. So those were the two main factors, and then management from a farming point of view, I think, is what put most pressure on. But certainly we have animals in this trial that we were looking at their worm egg count and thinking, oh, they should be dead, and they weren't. And that was just very non-scientific. Adam's going to hate me for that because that's not stat. I'm just putting it out there. But we were, as vets, it was really interesting to think, okay, well, there are animals that can survive. Like, we're not even talking about growth here. We were having animals dying. So like, no, we can get survival in these conditions, and it's possible that we might get more conditions like that in the future, just the way things are going.
So going off farm and sharing a lot of lambs that autumn, and it's heartbreaking. I don't wish harm upon anybody, but there was times where we actually got to the point where we refused to share lambs that year because it could have been the death of them. They were in such poor condition. And again, there was a combination of lack of tolerance and lack of wormers being effective. So, despite the trial not looking, we didn't add protein, we didn't go and give them any nice, there was people with poor growth rates feeding creep, and we didn't do that. So, yeah, it was challenging, but like we say, I mean, you've got to, these things I don't think are going to become less frequent, and you've got to prepare for the worst. You've always got to prepare for the worst. Everything after that's a positive.
I've just seen in the questions there, didn't talk about nematode iris. What effect was that burden having on the lambs? Do you want to field that, Adam?
Yeah, so we I think we're sampling from July. So I think just from the data, it looks like we were catching the kind of tail end of the nematode iris peak. So we had we got a few reasonably high counts in the first couple of sampling sessions, but after that it kind of declined to sort of really low levels, and so we didn't really focus too much on nematode iris, not for this anyway. I've got a PhD student who's working more with this data, and she's going to take a more in-depth look at that. But yeah, I think because we missed the peak, we wouldn't expect to see huge amounts. But yeah, not something we've looked at as intensively as we have with the strong girls.
And then I've got, can you say more about where you're going? So where we're going is we are hoping to potentially expand the trial. What we need is to either look a little bit more at an overall picture of what a resilient animal looks like. So not only might they tolerate worms, but they might have a quicker kind of lambing to sucking time. They might have lower mastitis rates, they might have lower lameness rates. So looking at the picture of resilient animals in total, but also it would be really cool to see if there is proof that their genetic traits exist for tolerance. So we have designed a trial, and we've been looking at funding options for that. So that's hopefully where we might get to. It's just when you're reliant on Defra grants, they have this lovely habit of telling you 2 weeks before the deadline that you have to apply. So that's what we're struggling with a little bit, because the funding is needed. And I think that's something that was evident from the beginning, was actually it does take quite a lot of time to organise these things. So you do need to be funded for it. And the Moredun were fantastic. And the amount of work they did for the amount of funding was not a great ratio. So Moredun were fantastic partners in this. But yeah, we're looking for funding. Can expand on the relationship between lamb, fecal egg output and subsequent pastoral. So pastoral larval challenge due to high worm egg count. I think Adam, you might mentioned briefly that we've seen in New Zealand that these ones that are tolerating and have a high fecal egg count aren't actually building up larval pasture burden. But can you expand further on that, or if you want to provide the paper for Peter potentially?
Yeah, I can't think of it off the top of my head, but there's some it's work by Stuart Bissett, who did a lot of the work on resilience. So they have long selection lines of resilient and resistant animals, and they don't find a significant difference in pasture contamination between them. So the resilient animals, of course, that could be because they are also expressing some resistance as well. But what they tend to find is that the resilient animals, they tend to have higher egg counts, they have generally better weight gain, and they don't tend to have they have similar pasture contamination compared to their resilient lines. But that's just 2 lines, 1 study. So but that's kind of what we know about that at the moment. And in terms of our study, we don't know because we didn't do any kind of pasture sampling.
Again, on that particular question, looking at bits of data I've seen, unfortunately, from Australia, which pains me, but there's the refugia concept, which was basically dumbing down the worm population. So like the anthelmintics, like the antibodies, those worms, despite there might have been a lot less residue going out, they were smart worms. Whereas the worms out of the tolerant animals had not seen a challenge or less of a challenge. So by extending your periods between wormers or dependency on wormers, you could reverse a anthelmintic problem by basically desensitizing the population. So it wasn't necessarily a negative through the creation of refugia. So that concept for...
That's great. I think that's a really important point as well. We literally just don't have time to go into it. I'm looking now, it's already 7:30, Becky. There's a very one I can definitely answer. Clarification wanted. You're saying that only detrimental effect from worms to sheep comes when animals create an energy costing immune response. So no, that's not quite right, Tim, but it's a great question. So the main bad effect that worms have on sheep is that they will damage the gut lining. That leads to a drop in growth rates. That drop in growth rates happens before you even see scour, so before they start having diarrhea. That's the main problem with worms. But what we're saying is that if on top of having a high worm burden, if the way the sheep gets rid of those worms is by producing antibodies, she or he have to expend energy to make those antibodies. And that can be detrimental. So that can also drop their growth, not as much as being attacked by the worms and being really susceptible to them, but there is a little check there. So hopefully that clarifies that.
I think I'd say, sorry, just to nip in, I'd say as well, so that's an effect you sometimes see, and it's an effect you sometimes don't see. So it's dependent on the studies. Loads of studies done on this, and sometimes you get a negative correlation between resistance and performance, and sometimes you don't. And so it's a kind of potential cost rather than a kind of absolute definite cost that you're always going to see.
And yeah, so Tim's just asked then on the back of that, tolerant animals don't get as much gut damage from worms. I'm not sure we know the answer to that. I don't know if you agree with that, Adam. Do we know that tolerant animals don't get as enough damage?
Yeah, we don't know. We assume, so for most, the mechanisms behind tolerance aren't that well known in any disease system, let alone this one. What's sort of predicted is that generally tolerant animals are better at repairing damage. That's one potential mechanism they could be using, especially in this case where it's a kind of cumulative damage. And so if they're kind of constantly repairing it, that may help to limit the effects. But yeah, we don't know too much about the actual mechanism. It's all just sort of predicted at the moment.
And hopefully that answers Marjolaine's question as well. So I think that's what's exciting about this trial, is that it's so novel. We don't know, like a lot of what we've proven, we've then now got a billion questions to answer on the back of it. The trial wasn't repeated in 2023 or 2024, which was the other question. We didn't do any speciation because we didn't have the funding to do it. So all our funding was done on fecal egg counts rather than speciate them, essentially. Oh, and the only thing I have realised that does definitely need to be said, these animals were vaccinated against Haemonchus contortus, which we missed out saying. The reason that's important is that Haemonchus is a blood-sucking worm that can cause death, and these animals were vaccinated against that. That's a vaccine called Barbavax. If you're not using it, talk to your vet about using it, because we're seeing more and more Haemonchus. So that is an aside that I feel obliged to say from a welfare point of view.
I think after talking with Trevor Cook, who does a lot of, or is involved with a lot of research in New Zealand, who we were fortunate enough to have here on that dissemination day, there seems to be a tolerance towards Haemonchus, which is something that we will probably go into exploring. Hopefully we can get some funding towards it. However, on observation from sharing a lot of very different breeds, there is definitely some serious difference in susceptibility towards Haemonchus from certain breeds. So yeah, if you have one of those breeds, I would strongly recommend, like Lucy, talking to your vet about Barbavac.
Please do. It's a horrible, horrible disease, and we're seeing more of it in the UK. That could be the final plug of the night.
Great, thanks everybody. Yeah, we've reached time, so thanks everyone for coming. Thank you so much to our speakers. If you have any questions, I've put a link for a survey. It would be great if you can just fill that in, provide some feedback, and you can just leave your email there if you have anything you'd like us to follow up on. I don't think there's anything else for us to cover, so thanks very much for joining. Hopefully there'll be a lot more sort of research to come around that's things like the mechanisms around tolerance and yeah, all those questions like damage to gut lining, super interesting. So thanks very much, and I wish you guys all the best with funding in the future. We'll see how the pathway goes, but all right, great.
So much. And thank you to Innovative Farmers for having us as well. It's really
Yeah, thanks so much.
Our pleasure. Thanks. Bye-bye.
Bye.